Now let us solve some examples based on exponential growth and decay. A bacteria culture grows at a rate proportional to its size. After 2 hours there are 600 bacteria, and after 8 hours there are 75,000 bacteria. Then find the original population. Now here since it's given that a bacteria culture grows at a rate proportional to its size, clearly that is a case of exponential growth, and we know the solution of this particular situation, so we write that directly. There is no need to derive here. So if x represents the bacteria population at any instant t, it will be given by x0 into e raised to kt, where x0 is the initial population, and in this case we have to find out what is the initial population itself, for which we are given some additional conditions. Now it's given that from the start, after 2 hours have been elapsed, the bacteria population grows to 600. So therefore we can write 600 is equal to x0 into e raised to k into 2, because here t is 2 hours. So that is, in other words, we can write 600 is equal to x0 into e raised to 2k, just to make it look straightforward. So this is first condition. Similarly, second condition is after 8 hours. Now here we have to assume 8 hours have been counted from the beginning only and not after the 2 hours that have been already elapsed. So after 8 hours the population is 75,000. So therefore clearly we get 75,000 to be equal to x0 into e raised to 8k. That is our second condition. So now to get hold of x0, we have to first calculate k or some term in k. So therefore here we will divide second equation by first equation. As you can see, that is an easier approach. So that we will get 75,000 divided by 600 to be equal to e raised to 8k upon e raised to 2k, because x0 will get cancelled. And this is further equal to e raised to 6k, the indices will get subtracted. So that means e raised to 6k is equal to, let us cancel this, we have 125 as the value of e raised to 6k. Now see, it's not really required to calculate the value of k, because it's not the k that we are looking for. So let's keep this particular expression as it is, we will use it. Now let us substitute this particular information in one of the two equations that we know. Right? Now here we know that x0 into e raised to 2k is equal to 600. We don't know what is e raised to 2k, but we can adjust that in terms of e raised to 6k, right? Because we can write e raised to 2k as e raised to 6k upon 3, that gives us 600, and this we can write as e raised to 6k whole raised to 1 by 3 using laws of indices to be equal to 600. So therefore x0 into, now e raised to 6k we substitute as 125, and 125 raised to 1 by 3 is the cube root of 125, which is 5. So therefore we have x0 into 5 equal to 600. Therefore clearly x0 is 120. So that's the initial population which has been asked. Let's go ahead and solve another example based on exponential decay. Now here it's given that bismuth has a half-life of 5 days. Starting with 800 milligram of bismuth, how much mass will remain after 30 days? Now here, just to recap, what is a half-life of a radioactive material? It's the time period which is required to reduce x0 quantity of some radioactive material to half of it, that is x0 upon 2. So what is the meaning of 5 days half-life of bismuth is, whatever is the quantity that will get reduced to half in 5 days. Now after that time, for the further 5 days, the quantity that remains still gets reduced to half, and so on. Alright, so here let us write down the general solution of exponential decay. Now since it's a decay, note that we have used the minus sign. Now it's given that starting with 800 milligrams, so our initial quantity x0 is 800. So therefore we have x is equal to 800 into e raised to minus kt. Now it's been asked how much mass will remain after 30 days, right? For which we have to make use of the given condition, that is half-life is 5 days. So what it means is when t is 5 days, the quantity remained will be half of the original quantity 800 with which we started off with the experiment. So therefore at 5 days from the beginning, x would become 400. So therefore we have 400 is equal to 800 into e raised to minus k into 5. So therefore dividing by 800 we get 1 by 2 is equal to e raised to minus 5k. Now here also we don't really substitute or rather get the value of k as such, we can use it later. Now we have to find out at t equal to 30 days what will be the amount left. So let us write the general solution, that is x is equal to 800 into e raised to minus k into, now here it's given that t is 30 days. Now see, we make use of the relation that we already got. Let us adjust e raised to minus 5k somewhere so that we can substitute. So we have minus 30k, that can be clearly written as e raised to minus k whole raised to 6. So therefore since e raised to minus 5k was 1 by 2, that raised to 6, so that is 800 divided by 64. So therefore the answer turns out to be 12.5 milligram. So that means after 30 days only 12.5 milligram of bismuth would be remaining.